A first order liquid phase reaction A to B is carried out in two isothermal plug flow reactors of volume 1 meter cube each. So these are the two PFRs of volume 1 meter cube each, and A to B liquid phase reactor, where of course epsilon is equal to 0, is being carried out. The flow rate is given, the initial concentration is given, and the final exit concentration from the second PFR is also given. So we can easily calculate overall conversion, which is equal to 0.8. Now we know that n PFRs connected in series of total volume V gives the same conversion as one PFR of volume V. So if I replace this one with a PFR of volume 2 meter cube, keeping the flow rate and the inlet and the exit concentration same, it will be exactly the same. So this will give x is equal to 0.8, right? Now, from this data, we are going to take one important parameter out. So assume, let's say this is one PFR. This is a first order reaction. Of course, value of epsilon is equal to 0. Liquid phase reaction. Total volume is 2 meter cube. This is for a PFR for first order reaction. If we do that, then we get the value of K is equal to this. All details are shown over here. So with the value of K, now let's go to the actual problem. The problem says that if the two PFRs are replaced by two equal volume CSTRs to achieve the same overall conversion, what will the volume of each CSTR? Okay, so that's what we have to find out. So here the flow rate and the concentration, inlet concentration and the exit concentration remains the same, which means the overall conversion remains the same. So this is one CSTR and this is my second CSTR. Of course, the two volumes are remaining the same, equal volume CSTRs. So we know for n CSTRs in series, we know that this is the equation here. Of course, n is equal to 2. We already calculate the value of K. So tau I is the residence time in each CSTR. So if we do the calculation, we find that tau I is equal to tau 1 is equal to tau 2 is 0.1535 hours. So we know this is equal to V over F. We can say that we know the value of F. So we can easily calculate that the volume of each CSTR is equal to 1.535 meter cube. So what's the overall takeaway? The summary of this problem. For this problem, we of course have the same flow rate and the inlet concentration, exit concentration, first order kinetics, and this overall conversion that remains the same for two systems. One, we have two PFRs in series. This is PFR 1 and PFR 2, and another for one we have the two CSTRs in series of each volume V. So for the total volume of the PFR was 2 meter cube, 1 plus 1 for each PFR, and the total volume of CSTR is 3.07 because we have just calculated the volume of each CSTR is 1.535 meter cube. So ratio of CSTR PFR for two CSTRs and two PFR, which of course gives the same as one PFR of the total volume, is 1.535 for two CSTRs in series. Now let's very quickly see if there is only one CSTR. If there is only one CSTR and one PFR, then we know these are the standard equations for one CSTR, and this is for the PFR. So if you calculate the ratio of the tau, the response time, this becomes equal to 2.485. So for one CSTR for keeping the same conversion, the CSTR volume is almost 2.5 times the volume of a PFR. Now, as you increase the number of CSTRs keeping the same volume, of course, as you can see that the value of the ratio value keeps on decreasing. So at one point when n of course tends to infinity, total volume of CSTR will be the same as the volume of the PFR. We know that. Okay.